Welcome to Mr. Brown's Basement, a channel devoted to sharing the craft of repairing, restoring, and modifying vintage electronic gear, and other random stuff. I was indeed fortunate to get my hands on one of these. It's a Dynalogic Hyperion computer from about 1983. I picked it up near Oshawa, Ontario. The seller sold it as is. That usually means it doesn't work. When buying electronics as is, there's always the chance the guts have been mercilessly mutilated, like the Teleconcepts phone I acquired a few years ago. Sellers won't often disclose the disgraceful mess they've left, nor will they let you peek inside. Let's get some context for this computer. We have to go back to 1981. Things were very different in the personal computer world. Unlike today, when personal computers run Windows, Linux, or Mac OS, the market was fragmented between many systems, including those running MS and PC DOS, Atari DOS, Apple DOS, Tandy TRS DOS, GEOS, CP/M, and others. Things changed in mid-1981 when IBM released their Model 5150, also known as the IBM PC. With this modestly powered 16-bit platform, a standard began to emerge that displaced many of the 8-bit systems that had dominated to that point. But IBM seriously underestimated the popularity of the PC and was not able to keep up with demand, even though they were assembled with mostly off-the-shelf, readily available parts. This created the perfect environment for other companies to fill the gap and flood the market with look-alike and work-alike computers. And they did. These computers were usually called PC compatibles or clones. And there were a lot of them. The original PC and clones were large boxy desktop machines weighing 24 to 30 pounds, not including the CRT monitor that sat on top. The original IBM 5153 monitor was another 26 pounds, so it wasn't what most would call portable unless you were the Incredible Hulk. In early 1983, Dynalogic introduced Hyperion, the first portable PC-compatible computer. It's shaped like a PC with a 7-inch monitor on one side. A couple of months later, Compaq released a PC-compatible they aptly called the Compaq Portable. It weighed 28 pounds with a built-in 9-inch monochrome CRT display. It's shaped something like a chubby suitcase and gave rise to the term luggable, which was a much better description than portable, because the so-called portables needed to be plugged in to operate. It and others would eventually kill Hyperion because it wasn't quite 100% PC compatible. Let's look at Hyperion. It was a featherweight at only 18 pounds, including a built-in 7-inch monochrome monitor. Storage was a pair of IBM-compatible 360 kilobyte 5 1/4-inch floppy disk drives. A hard drive was an option, but I'll get to that later. Hyperion had a better ergodynamic design than many of its competitors. The keyboard tucks in neatly underneath. On the back, it has a serial port for connecting to other computers or to an external modem. It also has a parallel port, which was often used to connect to a dot matrix printer. And it has a connector intended for an expansion unit, which could accommodate a hard drive, and up to 7 PC expansion cards. These expansion units are exceedingly rare. It also has a built-in 300 baud direct connect modem for connecting to remote systems using the telephone line. It has a video output which could connect to a composite monitor or even to a television through an RF modulator, and it's one of the few systems designed and made in Canada. Internally, it had 256 kilobytes of RAM, which could be expanded to 640 kilobytes if you had the expansion unit. The processor, a 4.77 MHz Intel 88, was the same speed as the IBM PC. It did have a socket for a math coprocessor. In 1983, Hyperion could be yours for $4,995, which was much more money than an IBM PC plus monitor. Nevertheless, it garnered much attention for being portable, or luggable, whatever you want to call it. I've plugged it in, and it does not power up. So let's take a look inside and hope that this is an easy fix. I'm going to start by pulling out the keyboard, and underneath, way at the back, is a place where the keyboard plugs in. It does not unplug at the keyboard end. This is what an old keyboard connector looks like. You can see the plastic is deteriorating. I am going to investigate replacing this because a good part of the connector is gone. It's a standard keyboard with a keypad and some function keys. There are no arrow keys, at least not what we're used to today. It was made in May 1983. I would love to know what revision this is because there were several different revisions. There are a pair of screws under the handle which have been undone for me, except I don't know who undid them. That's not encouraging. Underneath, there are 2 screws on the bottom. One has already been loosened for me. How nice. And 2 more screws by the feet. Taking off the back case half reveals 2 large printed circuit boards. The rear board is the display and I/O board. The daughter board is the 300 baud modem. There are many TTL chips and a few multifunction chips. This is the Z80. This is the root of the incompatibility with IBM PC serial ports. These are the high-speed video RAM chips, 20 kilobytes for the screen. It almost looks like there might be some water damage. I don't know. That's the monitor, and this diagonally mounted thing here next to a fan is the power supply. What I'd really like to do is test the power supply, because that's the root of everything. If that doesn't work, then you wouldn't expect anything else to work. I already suspect that the switch is bad. Hopefully that's all it is, but there could be more to it. This is a switching power supply with large high-voltage electrolytic capacitors, which must be discharged if the power supply has been operated for any length of time before I can touch it safely. That's unusual. It's wax potting material from the cup attached to the monitor's flyback transformer. Usually that cup only contains high-voltage diodes and capacitors. It could either be a filter circuit for the picture tube, or it could be a voltage doubler or tripler. In either case, I've never seen one get hot enough to melt the potting material. What must have happened is the horizontal output transistor or the flyback transformer must have got really hot, or perhaps something else did. The speaker is probably garbage now. I really want to isolate the power supply and see what, if anything, it's doing. That's going to mean removing the logic boards. I don't think I can get to the power plugs without doing that. This is the modem board, and it's held in with 2 screws. So it should just come out once I take these screws. It will plug in with a mating connector into this board. 2 of these screws. There's the modem. I don't think this has touch tone. I'd have to look more carefully. This rear logic board is held in with 3 screws that I see. There's another long connector. There's a connector there. Each of these 3 screws go through unthreaded standoffs into threaded standoffs. Lots of parts to lose. These plugs just came out. Now, tantalum capacitor. These are notorious for going short. Readily available, I just don't think I have any. That plugs out right there. The board is also held in at the connectors with these hex standoffs for the serial and parallel connectors. They used to be very hard to acquire. And there are a couple more screws at the bottom. Short screws. Connectors on the top. This is a disk drive connector. And I don't know what this is, but it's out. That looks like a speaker wire right there that needs to be unplugged. This is the inside board. It's got some ROM on it. '8088. It's a little troubling to see something that connects to nothing. And I didn't unplug this, but it certainly looks like it was intended to connect to there. I don't know yet. That would make sense, because it's right there. Anyway, the main logic board is disconnected. That leaves the display. The drives are still connected. Let's see if the power light comes on when I plug it in now. Now, it looks like it's lighting up, but I don't know whether that's my light or the light from the power supply. That answers the question. Either the switch is bad or there's something else happening. Yes, I just lost the plunger somewhere. Well, there's the switch. Looks like somebody's been playing around with it. Looks like the switch body is broken. Here's the lamp that plugged into the power switch. It's dead. 18 volts, 26 milliamps. It's a miniature bi-pin bulb. They might still be available. I can guarantee that I don't have one. It looks like the push-on, push-off mechanism continues to work. Maybe it's just come apart or somebody pulled it apart. Anyway, I can apply power and see what happens. What I'd hoped to see is the heater inside the cathode ray tube lighting up, and it's not. Or hearing the horizontal or vertical oscillators from the monitor, which I'm not. So let's take out the power supply and see what that looks like. The power supply is held down with 2 bolts, and then I should just have to disconnect the disconnected mains. But this power connector, and perhaps one more I can't see, and then it should come out. And the power supply is out. Switching power supplies can be a headache to repair. I'm hoping this one will not be. None of the capacitors look to be bulged, and the fuse is intact, but I'll double check that with a meter. I will apply power to it, and there's line and neutral right over there to see if it does power up with nothing connected. One troubling thing I see, which needs to be dealt with if this is ever going to be put into service, is that there are 2 REFA capacitors, one there and one there. They are known to explode with a lot of force and a really bad smell. This is 0.1 microfarad. It's a safety capacitor. That's what the X is for. That's the same thing over here. That in itself would not prevent the power supply from working. There's got to be something else. Maybe it's fine, but even if it's fine, those 2 capacitors need to go. Now, a quick visual inspection, because that's what you always want to do. There are no burned resistors. Nothing visibly cooked. Looks good. It's made by Aztec, a manufacturer well known for its quality power supplies. There are the specifications of the power supply. 5 volts, quite a bit, 7.3 amps. On plus 12, a total of 2.5 amps. And on what might be minus 12, maybe there was a minus there, but it's gone, is 0.1 amp. As far as I can tell, the minus 12 is used by only one chip on the direct connect modem board. Interestingly, the 4 screws that held this to the mounting frame were also loose, which means somebody's been here before. Perhaps they decided that it couldn't be fixed. There's a classic reefer capacitor. The first step before exploding is cracking on the outside as the pressure inside builds up. And as you see, it's cracked. It's not going to explode for anyone now. We can power it up now and see if it does anything at all. Hopefully no fireworks. No fireworks, no sound. Got to check some voltages on the output. I measured the voltages on the output and I got 0. So that's fundamentally why the computer is not powering up. There's no power. Fortunately, there is a schematic available for this power supply. Here it is. I know the fuse, which is right over there, is good. Assuming choke T1, bridge DB1, resistors R1 and R2 are good, and capacitor C5 isn't shorted, then I should get voltage, quite a bit of it, across C6 and across C8. And I measure 332 volts, which is reasonable. I also measure 332 volts at T2, which rules out R14. I desolder and test main power transistor Q2. It's fine. I test diodes D2 and D4, resistors R9, 11, 12, and 13. Anything that could interrupt power to Q2, they're fine. I measure incoming current. I get less than 2 milliamps. I conclude that I'm measuring the current through voltage divider R3, R4, and R6. I desolder one leg of R13 and D2. I measure the resistance across the coil. I get high resistance. I conclude then that the transformer is roast. No, it's toast. So I need a new power supply. A little information on this switch. It's made by EAO 11-271-825. This is what it should look like. But this is not what it looks like. It's likely that someone over-tightened it and broke off the threaded shaft. And the current price, because they're still available, from Mouser or DigiKey is about $90 per switch. Not happening at $90. If I apply 12 volts to one of the disk drives, it's moving, drawing about 0.13 amps. And applying power to the other one, 0.13 amps. So at least the disk drives will do something. This should energize the CRT. It's drawing no current at all. I will be doing more troubleshooting and trouble solving, but I don't want this video to get too long. I must decide what to do about the dead power supply and about the very expensive switch. I have to investigate the monitor further to understand why it's drawing no current and figure out why the potting material liquefied and ran all over the speaker. That will be for the next video, and I hope you'll join me for it. I hope you enjoyed this video from Mr. Brown's Basement. Please like, subscribe, and comment, especially if you have experience with this very sick and odd duck of a computer. As always, thanks for watching.